Hello everyone, welcome to my channel. Let's solve this question together. Now we are given what? The integral of x squared divided by x to the power of 3 plus 1 dx. We are asked to integrate this function with respect to what? X. Now our first step, what you're going to do is to let any variable represent what? The denominator. Okay? So we are not wrong if we say let what? Let x to the power of 3 plus 1 equals to what? U. Now from here, let's make x the subject of the formula. So we will have to subtract 1 from both sides, right? So we're going to see that x to the power of 3 is equals to u minus 1 because we subtracted 1 from both sides, right? Now our target is to make x the subject of the formula. We can use two options. You can either do what? Multiply both power by the reciprocal of 3, or we'll take the cube root of both sides. Let's take the cube root of both sides. The cube root of x to the power of 3 is equals to the cube root of what? U minus 1. Now this cube root will cancel out this cube. So now that our x is equals to the cube root of what? U minus what? 1. Wow. This is pocket genius, right? I love this. Amazing. Now let's go back to our this. Let me say this is equation 1, right? Okay. And this we are getting that this is equation 2. Okay. Let's go back to equation 1. Equation 1 says that x to the power of 3 plus 1 is equals to what? U. Now, from this equation 1, let's differentiate u with respect to x. That means the u over the x will be equals to 3x squared, because if we differentiate a constant in differentiation, it's always what? 0. Whenever we differentiate a constant in differentiation, it's always what? 0. But if we integrate a constant in differentiation, it's not 0. Take note, okay? Now, from here, what are we going to do? Remember, we'll differentiate 3x to the power of 3. Remember, the coefficient of x to the power of 3 here is 1. So this power will multiply by the 1. That's why having 3, because 3 times 1 is 3. Then if we subtract 1 from the power, you have 2 here. Remember, in differentiation, we always subtract 1 from the power. But integration, we always add 1 to the powers. And you see how interesting it is? Now, from this point, let's make the x the subject of the formula. Don't forget that the denominator of this 3x squared is what? 1. By cross multiply, 1 times the u, we're going to add this is the u, okay, equals to the x times this one, this is into 3x squared, okay, multiplied by what? The x. Now at this point, what you're going to do is to make the x the subject of the formula, right? So let's divide both sides by 3x squared. So if we do that, we're going to see that the x is equals to the u divided by what? 3 what? 3x squared, because I divided both sides by 3x squared. Now this is the x, right? So we can call this equation what? Equation 3. Wow, this is amazing. Now let's go back to our original equation. Our original equation is the integral of x squared divided by x to the power of 3 plus 1 dx. That means we are integrating this function with respect to what? X. We are going to add that this is what? The integral. What is x? Look at x. X is what? Is what? Cube root of u minus 1. So x is what? The cube root of what? U minus what? 1. Okay. Don't forget that this x you're seeing have a power of 2. So here is what? 2 divided by, now the denominator here is what? Look at x to the power of 3 plus 1 is now u. So this is what? Just u, right? And what is about the x? Our the x is what? Our the s is what? The s is the u divided by what? 3x squared. Wow, this is pocket genius. I love this. Amazing. Now what we are going to do here is to let all the alphabets here represent u, not x. We want to isolate x out. Want to remove x out. So this now becomes what? The integral of into the cube root of what? U minus 1 all to the power of 2 divided by what? U. Then multiply by what? The u divided by what? 3 into what is x? X is cube root of u minus 1. So x is what? The cube root of what? U minus 1. Don't forget that this x has the power of what? Of 2. Wow. Wow. This is amazing. Now what are we going to do? Observe carefully. You can see that we can do something very interesting, right? Now, if this cancel out this, because they are the same. So now this is what? The integral. This divided by this is just 1 divided by what? U. This have already cancelled. So you have to multiply by the u divided by what? 3. Amazing. Amazing. Wow. I love this. Now, what are we going to do here? Remember that the coefficient of the u is 1 over 3. The coefficient of the u is what? 1 over 3. Let's isolate the coefficient of the u. Okay, the coefficient of the u is what? 1 over 3. So if we do that, this is 1 over 3, the integral of 1 divided by u du. Wow, this is amazing. Now remember that in that different integration is a process of finding the antiderivatives of a function. Whenever we have a function of the integral of 1 over u du, what you have to do is just to take the natural logarithm of the denominator. Why? Because since the numerator is already been differentiated, because the numerator here is being differentiated. So if you differentiate the numerator and look exactly the numerator, we just take the natural logarithm of the word denominator. That's amazing concept, okay? So what I want to do here is just to have 1 over 3 ln u plus our integration constancy, and we are done. Ln u plus our integration constancy, and we are done. This is the answer. But remember, what is u? U is s to the power of 3 plus 1 equals to what you look at. So this now become what? 1 over 3 natural logarithm of into s to the power of 3 plus what? 1 plus our integration constant c. This is the answer to this question. Can you see how simple and interesting it is? Very, very simple and interesting, right? Now, let me show you another short way of doing this without passing a lot of stress. Now, let's go back to the question. The question is what? The integral of s to the power of 2 divided by s to the power of 3 plus 1 dx. Now, let me show you something very interesting in this video. Now, we're having s squared divided by what? The integral of s squared divided by s to the power of 3 plus 1 dx. Now, take note of this. Whenever you have a function like this, and when you differentiate the denominator, it look exactly the numerator. Just take the natural logarithm of the word denominator. Take note of that, it's very important. Whenever you have a function, and if you differentiate the denominator of that function, it look as exactly the numerator. Take the natural logarithm of the word denominator, and that is the answer. And don't forget your plus integration constancy. I said that I want to show another interesting method of doing this without wasting of time. Without wasting your time. Now, given a function of the integral of s squared divided by s to the power of 3 plus 1 dx, I don't want to waste your time passing through all this stress, this process. You know that there's an amazing thing you can do. Now, I want you to understand something about this function. Now, this function is what? The integral of s squared divided by s to the power of 3 plus 1 dx. Now, take note. Whenever you have a function of this form, okay, and if you differentiate the denominator, it look exactly the numerator. Just take the natural logarithm of the denominator. That's the answer. And please don't forget your plus integration constancy, which is very important. Okay. But what are we going to do here? Because if I differentiate the denominator, look at the denominator here is s to the power of 3 plus what? 1. If I differentiate the denominator, I'm going to have just 3s squared. But 3s squared is not the same as what? S squared. Do you know that 3s squared is not the same as s squared? So what will I add to this? The numerator that will look exactly the denominator if I differentiate it. Now look at amazing thing I'm going to do. So if I have this as the integral, okay, as 3, if I add 3 to this x as s to the power of 2 divided by, okay, divided by x to the power of 3 plus what? 1, then the x. If I add 3 here, I have to add the reciprocal. I have to multiply it by the reciprocal so that it can cancel out. It does not mean anything because it's still the same thing. So if I add 1 over 3, the integral of 3s to the power of 2 divided by 3s to the power of 3 plus what? 1 plus our integration plus dx, right? Now, there's nothing changed here, my brothers and sisters. This equation you're seeing here, this function is something like this function. Do you know why? Because this 3 can cancel out this 3. So I'm still left with this function. Now, since you have me s to the power of 3 here, and if I differentiate this, if you look exactly this, I'm good to take the 1 over 3 multiplied by the ln of the denominator, which is s to the power of 3 plus what? 1 plus my integration constancy. And that is it. That is it. That is very simple. Now, what you have to observe and understand in this function is that whenever you differentiate the denominator and it looks exactly the numerator, just take the natural logarithm of what? The denominator, and that is it. Can you see how simple and interesting it is? Very, very simple. If you know you find it very interesting, don't hesitate. Do well to like, comment, and share to loved ones so others will learn from it. Please, if you're not subscribed, consider to subscribe to this channel so anytime another exciting video, you notify. So thank you so much, and God bless you. Bye.